So my talk is in some sense, as Xinwen hinted at on Tuesday, it's like a direct continuation of his talk. So Xinwen motivated. I should use block letters. Yeah. So he motivated on Tuesday by some kind of conjectural formula for the cohomology of Shimura varieties that there should be correspondences. I'll just write big. So there should be, yeah. So I like this word exotic Hecke correspondences. Between the mod P fibers of different Shimura varieties. So the mod P fibers of maybe extended Shimura varieties. For two different Shimura data, so GX and G prime X prime. If G prime is or maybe extended pure inner form of G. So if G prime, let me just say like this, so it's an automorphism group of Z, where Z is a Q torsor, is a G torsor over spec Q, trivial over the finite adels away from P. Okay, so I'm allowed to change my group at infinity and at P. And Xinwen explained that, or he sort of explained his joint work with Liang Xiao, where they prove this when the groups are the same at P, and maybe they're unramified and quasi-split at P. And the Hodge type, of course. Okay, so I want to talk about what happens when the groups are different at P. But first, I thought I would start by giving some examples. So first, some examples. And these examples are basically all due to Chen and Zhao. So the first one is I take F real quadratic. And I take, so my examples will be a little bit strange because my examples will all not be of Hodge type. They'll be of abelian type. And you have to change them a little bit to get actual examples of the theorems. So experts will know what I mean when I write G2 and X2 here. So I'm going to take GL2, so restriction of scalars of GL2 with the usual product of the upper half planes. And yeah, maybe I'm always fixing C isomorphic to QP bar. And then I get correspondences. So then Chen and Zhao prove construct correspondences. So mod P. So at the split prime to kind of G2 prime X2 prime, which is the Shimura curve for the quaternion algebra, which is split at one infinite place and one prime above P. So this is restriction of scalars F over Q of, let me write D infinity 1 P1 and kind of the Shimura datum is upper half plane times a point. Of course, there's also the other one where you take the other place at infinity, the other place at P, and point times H. Okay, I mean, in their case, they don't just construct an abstract correspondence. They prove that if you look in this Hilbert-Modular surface, then there are two Newton strata that are one-dimensional, like ordinary times supersingular and supersingular times ordinary, and they prove that ordinary times supersingular are just isomorphic to the Shimura curve. Okay, so in that sense, the correspondence is very explicit. Okay, and so this example is used in work of Caraiani and Tamiozzo. I hope I'm not misspelling Matteo's name. So it's used in this work of Caraiani-Tamiozzo to get that the Igusa varieties corresponding to these Shimura varieties are, so the Igusa variety for this Hilbert-Modular surface is isomorphic to the Igusa variety for this Shimura curve. Those statements are very closely related. Okay, so this is not an example of the theorem of Xiao-Zhu because the groups are different at P, but it will be up to changing the center. It will be an example of the theorem I will present. So another one is let me take F cubic, totally real, and P inert, and I take G as before. So it's just the Hilbert-Modular threefold, and I take G2 prime X2 prime to be again the Shimura curve. So Shimura curve. So for kind of a quaternion algebra, I choose two infinite places. So G infinity 1, infinity 2. Maybe I'll write this restriction of scalars in here, or restriction of scalars of this quaternion algebra at infinity at like any two infinite places. And again, there's a similar kind of statement that there's a kind of like one-dimensional Goran-Ort stratum which is isomorphic to the Shimura curve. Okay, but in this example, there's something that they don't construct because there should be another kind of G2 double prime, X2 double prime, which corresponds to another quaternion algebra. So I want infinity 1 and P. Okay, so this is some quaternionic Shimura surface, which is at non-quasi-split at P, so the group is different at P, and I expect that there's also correspondence here. And I don't think Chan and Zhao write this down, although I'm sure they could if they wanted to. But so this is the kind of, and maybe for experts later, this one is important to keep in mind, because I'll say it already. In this case, the biggest Newton stratum in this quaternionic surface does not receive any special points. That will be kind of relevant later. So are there any questions about these examples? So yeah, and I'll give some like more general examples later. So, but I think these are good to keep in mind, because somehow the general picture is not so far away from this. You just write G speed to G or some orthogonal group instead of GL2. So then the question is, what results do we expect? So my collaborator, Jack Sempliner, so everything, I'm not sure I said this, but everything is joint work with Jack Sempliner. So my collaborator worked out in a function field case exactly what's going on. And I don't really have time to explain this, but somehow, if the groups are, if G and G prime are like extended pure inner forms in the sense of quadfits, and some like conditions are satisfied at P and infinity, then you expect to get some correspondences or some Igusa varieties that agree. So I will not talk about extended pure inner forms, although, well, I don't know where Shinwan is, but maybe for abelian type Shimura varieties, you expect that if you have two abelian type things that are extended pure inner forms, you can always like massage the centers to get Hodge type things, which are then pure inner forms. So the theorem I will state is for pure inner forms, but I suspect that this will kind of be, I mean, okay, you have to be careful, right? Because in this case, here they're really not pure inner forms. GL2 does not have so many pure inner forms. They're really extended pure inner forms. But so the way you prove this is you go to some auxiliary unitary Shimura variety where they are pure inner forms. That's somehow sort of secretly happening in Chen and Xiao. If you want to change, if you want to change the group, you have to sort of go to an auxiliary Hodge type thing where you really have pure inner forms. Okay, so what do we expect? Just in the case of Shinwen, we expect some correspondence which is like pulled back from a local correspondence between spaces of Stukas. Okay, so recall. Yeah, in this GL2 case, yes. But you have to choose one where the you have to choose an imaginary quadratic field where P is inert. So the kind of auxiliary, like the Hodge type thing you're going to choose will depend on P. So what we expect is some correspondence which is kind of pulled back from a local correspondence between spaces of Stukas. So in Shinwen's talk, there was this diagram. So maybe I'll write Shimura mu so I take the canonical integral model. Okay, maybe I need to make some choices, but I'll explain the notation a bit more. But this is like the special fiber of the Shimura variety for GX at the place of the reflex field determined by my isomorphism between C and QP bar. And then I have my Shimura variety for G prime X prime. Okay, and then this maps to a space of local Stukas, which are roughly speaking p-divisible groups with G structure with the correct like determinant condition. Then I have Stukas, and maybe I should put a kind of G here. Okay, so I want to have some correspondence between these different spaces of Stukas, and if the groups are the same at P, then we're in good shape because these both map to kind of GQP isocrystals. Okay, so then you can form the fiber product and you get Stukas G mu dash mu prime. And you can ask for some, I guess, in scheme here. So you can ask for Shimura G. So making all these diagrams Cartesian. But you see immediately if the groups are not the same at P, then it's harder to define this local correspondence. Okay, so the way you do that is so at P, we observe that our torso Z gives us a class A in the H1 UG, which gives us an element A localized at P in H1 QPG. Okay, and this lies inside of BG QP basic. Okay, and if I give you a basic class, then you can use that to compare, Bun-G and Bun-G prime on the Fark-Fontaine curve, or G isocrystals with GQP isocrystals. So then, and maybe I need to choose some A in this kind of maybe I need to choose an element in this sigma quantity class, then choose A to get an isomorphism from G prime isocrystals to G isocrystals. And okay, just to be clear, this is only defined over FP bar, or it's defined over the this A lies in GQP brev. If it lies in GQP to the n, then it's defined over FP to the n. So this is really only defined over FP bar. Okay, and then I can play the same game. I can put this maps to GQP prime isocrystals, and let me label this map by AP. I could play this game. So I can build a new correspondence, but now it depends on, again, it really depends on this class AP. So that's kind of the result you might expect. And yeah, and for this, I mean, it would be fine if A was some like extended pure inner form, like some global Kollwitz class. You could do the same thing. The reason that's not so good for Hodge type things is I want to do something with the abelian varieties in the end, and this means if I push forward to some symplectic space, there I want to have the trivial correspondence in terms of like quasi-isogenies of abelian varieties. Okay, so this is maybe the expected result, that you get some imperfect in scheme sitting in this diagram. Okay, and then but let me state some results. Oh, maybe one more remark. So this looks a little bit scary, but in these kind of unitary Shimura variety examples, this is a moduli space of abelian varieties with extra structures. Some extra multiplication, some determinant condition. This is multiplication by the same CM field, some different determinant condition. And this is just like p power quasi-isogenies between these abelian varieties with different determinant conditions. Okay. So in the end, this really has, in the PL case, it has some moduli interpretation. And this is, p-divisible groups with the same structures, p-divisible groups with the same structures, p-divisible groups of the quasi-isogeny with the same structures. So in the PL case, all these things have much more classical explanations. Let me find some chalk. Okay, so main results. Am I still writing big enough? Okay, good. So first of all, I'm gonna ask that P is not 2. And I'm going to fix maybe I want GX to be of Hodge type, so I'm going to fix some Hodge embedding into the Shimura datum for some symplectic space phi. And I want, so first of all, I kind of want to put my both my Shimura varieties into the same Hodge, into the same Siegel space, just like in Shinwen's talk. So I want that kind of there's some I prime from G prime to GSPV. Again, this is defined up to conjugation because the class will be trivial when pushed forward to GSP to be a Hodge embedding. Be a Hodge embedding. For X prime. So Shinwen explained there's some concrete condition in terms of like Kollwitz sets at the real place that guarantees this. Maybe I won't repeat that. Okay. So I need a technical assumption. So, and I'm not sure I'll be able to explain where this comes up, but this is, I need the image of G intersect with SPV to be connected. So all the reasonable examples of Shimura varieties I know, this is always true, but you can write down counterexamples. Okay, and so then, right, I'm going to choose some. It's best if I choose some elements. So I have these two embeddings into GSPV and GSPV of these different groups, but the groups are isomorphic over the finite adels away from P. And in fact, the embeddings are conjugate. So I'm going to choose some T upper P conjugating I to I prime. which induces a kind of G of the finite adels away from P, is G prime of the finite adels away from P. Which means I can compare the levels away from P. So then theorem okay, and again, I've been slightly too naive in this expectation because I have to put the superscript extended above all the Shimura varieties, but I'm going to forget that. So maybe I'll add another assumption that there's no SHA. SHA QG is 0. So I don't have to, and this makes most of the statements easier. And again, in the examples I'll write down, this will be true. But there are some natural examples, like some I think even unitary Shimura varieties where it fails. So, but something can be done if you're willing to do extended Shimura varieties. Yeah. Okay, so, and maybe I want to, maybe I need another bit of notation. So choose KP prime in GQP and GQP prime. Say Iwahori. And really what I want my Shimura variety mu is I take my canonical integral model, say in the sense of Papa's rapport. So I take Shimura variety, I'm going to take the inverse limit of the Shimura variety SKP KPGX. And then I take the special fiber, and I also take the perfect scheme underlying this. And similar for so this is just a way to get rid of the level away from P in the notation. And now I can say things like there's actually an action of the prime to P Hecke groups. Okay, so let me put the theorem on the other side. Okay, let me also make one more kind of assumption. So I've made an assumption at infinity, which comes down to that this I prime is again a Hodge embedding. I need to make some assumption at P because I would like my local correspondence to be non-empty. Okay. Otherwise, the theorem is kind of vacuous. So the local assumption at P is saying that if I take Kg, so the Kottwitz invariant of mu, so the Shimura co-character for G, and I can compare this with the Kottwitz image of mu prime, but I have to add the image of my class AP inside. I mean, Shinman likes to write this in terms of the center of the dual group, but I just write the algebraic fundamental group. And these things are identified because they're inner forms. So this condition is precisely saying this local correspondence space is non-empty. So in Shinwen's case, he was asking that these are equal without this term here. Okay, that's just saying the local correspondence space is empty. Otherwise, the theorem is vacuous. So theorem. Yes.
Action by this different signature. So then to have something in this correspondence, can you just consider isomorphisms which do not and you just forget about it?
Yeah, so about the signature condition, yeah, like in characteristic P, isogenies can of course change the signature. So yeah, you look at like I would say P power like quasi isogenies between the P divisible groups, preserving the action of the endomorphism algebra, but nothing else. Maybe also the polarization. So now I need to say if GQP splits over an unramified extension, let me just see if I'm missing something. Yeah, and the 4 assumptions hold. So 4 assumptions above hold. Then this Shimura variety mu dash mu prime, depending on A, exists. I mean, it sits in the diagram, in the expected diagram. And the left and right things are Cartesian with left, right square is Cartesian. I guess okay. I guess there's 5 assumptions. Okay, let me go over them all. P is not 2. I need this connectedness assumption. I have my stage half radius group is trivial. I have my assumption at infinity and my assumption at P. Okay, so yeah, so 2 of those are definitely natural things to assume, and the other 3 are just technical assumptions. And let me just say, I mean, it's a perfect in scheme. So I mean, it's a non-empty. Right. So let me start to write some properties of these maps. So these maps are improper. I guess they're in the perfectly proper. So I mean, it really tells you that I know what the image of this map is, because I know what the image of this map is. The image is a unit of Newton strata. Well, which Newton strata are that? So I take basically the Newton strata that appear in the cohomology of Newton strata that appear in a special fiber for the Shimura variety for G, and I kind of intersect with the Newton strata that appear in the cohomology for G prime under kind of this map from BG prime to BG. So I'm describing the image. So I'm saying the image is the image of these like the source and target maps of the correspondence. They're a closed unit of Newton strata. Which Newton strata? The one you expect from down here. So these are improper. The fibers are affine Hellenistic varieties. So the fibers of this are affine Hellenistic varieties for G. The fibers of this are affine Hellenistic varieties for G prime. Yeah, but essentially, like all the properties I'm naming come from properties of this local correspondence. Which are just some local thing you can compute.
But it's not obvious just from that you have to try.
Sorry?
Just from this existence of this local correspondence, it's not obvious with the rest of the diagram.
No, that's right. I mean, in fact, it's very easy to define what this should be. It's some like modelized space of quasi-isogenies between abelian varieties. But as Shinwan explained, why is it non-empty? That's the whole point. And of course, these diagrams both being Cartesian tells you that it's non-empty. But that's very hard. Of course, I can take this fiber product, but it will not have a map here.
Right.
Yeah. So okay, let me state the second theorem. Maybe I should just say for the people who weren't here. So remark. This is due to Xiao-Zhu. If GQP is quasi-split, and this AP is 1, Okay, so we allow, you know, the trivial class, but the groups being non-quasi-split, for example. But also we allow the groups to be different. Yeah. And also, you know, the groups could be the same, but the class could be non-trivial. I'm not sure there are interesting examples of that, but this is a possibility.
Oh. I mean, it's like trivial.
Yeah. Yeah.
Then take this intersection. I mean, aren't these two sets actually the same?
No. For example, if A is trivial and identify G and G prime, then mu and mu prime might still be different because my groups could be different at infinity. Right? For example, like one group could be compact at almost all infinite places, so the Shimura variety is very small, while the other one could be non-compact at all infinite places, where the Shimura variety is very big. So yeah. So in many cases, it's actually true that one of them is contained in the other, like the example I just mentioned. Okay, so let me state the result about Igusa varieties.
Can you take care of the case like one level of the factor?
Yeah. So the level at P doesn't matter. So like I'm just stating them both Ibahori, but somehow as soon as you have I guess there's some diagram involving just the Shimura varieties for G and the Stukas for G with different levels, which is Cartesian. So you can kind of, as soon as you have the correspondence for one level, you can make it the other level. Yeah, I mean that relies on knowing enough about uniformization of isogeny classes. So let me give a new example. Which I think of as kind of like a sort of typical example. Actually, maybe I'll state the other theorem first. So theorem 2, again, with Jack. So again, if GQP splits over an unramified extension plus the other assumptions, then for B and GQP breve, such that its class is in BG mu intersect with BG mu prime, G prime mu prime, we have a JBQP times G of the finite adels away from P, equivariant isomorphism from the Igusa variety for B with the Igusa variety for B prime. Okay, so yeah. Let me not tell you what B prime is, but B prime is somehow, is the image of B under some isomorphism between G and G prime over QP breve. Okay, these Igusa varieties are isomorphic. So this generalizes a result of, or it's very close related to results of Caraiani and Tamiozzo in the GL2 case. So I should say, I think it's been observed independently by many people that this is a result that this is a consequence of results of Xiao-Zhu. So this is Xiao-Zhu plus, let me say 2 epsilon somehow. So 1 epsilon is this observation, and the second one is if you want to get JBQP equivariance, you need to work a little bit harder than, so maybe if you don't know what an Igusa variety is. Sorry? P is not 2. Yeah. Okay, but the Igusa variety is essentially it's the fiber of this map over a point in the Stukas. Okay, so that's what it is. You take a map from FP bar to here, that gives you an Igusa variety. So this correspondence definitely gives you isomorphism of fibers, but to get the whole JBQP action, you have to work a little bit harder. And the best way to do that is to think in terms of these kind of there's a perfect analog of these Igusa stacks that Ming-Jia Zhang writes down in her thesis. Okay. So yeah, this is sort of Xiao-Zhu plus 2 epsilon when again GQP is quasi-split, and this class at P is trivial. So yeah, let me give the example and then go towards the proof. So example, again, F totally real, P totally split. So say it's like P1 up to PD. And then again, I'm going to take something of abelian type, which is restriction of scalars F over Q of G is P to G. And G2 prime, X2 prime is the kind of unique inner form trivial away from P and infinity, trivial over AFP, such that G2 prime R is GSP to G R times something compact mod center. Okay, so I'm changing the group at all but one infinite place. And also, I want G to QP, again, is GSP to G QP times, again, something non-quasi-split. So yeah, at all but one finite place, again, yeah, and sort of these places are related via an isomorphism of QP bar and C. All but one finite place, I'm changing the group as well. Okay, and now if you want the kind of relevant Shimura varieties of Hodge type, I have to choose some imaginary quadratic field to build some Hodge embedding as the lean does, but I have to make sure that P is inert in that imaginary quadratic field. Because otherwise, I don't get pure inner forms. Yeah, so essentially you write down the model étrange that the lean writes down, where at a prime, so for an imaginary quadratic field where P is inert, and then you compute the cohomology and you see that there are exactly the classes you want to see lifting the inner form for the adjoint group. Okay, and you can essentially do the same thing in type B and DR, I think. You take restriction of scalars of some G spin thing, totally split prime, and you're going to change the signature to 0 at kind of all but one, I mean, I don't have to do all but one infinite place. I can just do however many I want. So, and I think in type DH, it's probably more complicated, but and somehow it is very important that P is not 2, because all the cohomology classes you're going to see are all two torsion cohomology classes. So when P is 2, I think it's going to be much more complicated. Okay. Right. So basically, what I need to do, if I take some B, which is like basic in all the other directions, then that it applies to those B. So I need a B which is whatever in this direction and basic in all the other directions. Right. So in some sense, all the Igusa varieties for G prime come from Igusa varieties for G in these kind of examples. Okay, so let's talk about the strategy. So yeah. So that's a very good question. So somehow this, like, choosing a Shimura datum is kind of, that's too much information. Like, really, you should these things should only depend on the underlying rational Shimura datum, maybe in the sense of Sempliner Taylor or something. But yeah, there should be like some better way to phrase this, right? Like, I can build correspond. That's not what you mean. Yeah, that's a very good question. No, that's right. Yeah. So probably for Shimura varieties of Hodge type, it's pretty close to being unique because you say, okay, under every Hodge embedding or under one Hodge embedding, it has to map to quasi-Schrödinger's of abelian varieties. No, but I think that is a good question.
No, but is the question really about unique local object or
Yes. Yes. And the answer is I don't know. And even when G is G prime, you could try to characterize this object, and that I don't know how to do. Yeah, and it should be compatible with kind of the extra structure, so the prime, the P. Yeah, but I don't know. I mean, yeah. So even when G is G prime, I don't know how to characterize the correspondence from the Shimura variety to itself. Yeah, maybe that's. I see. So maybe Shinran tells me that.
I don't know. You don't have enough faith.
Right. Okay, so I want to discuss the proof, but first I have to explain why the entire theorems are not Xiao-Zhu plus 3 epsilon. So xz reduce to the case of tori. Tori using the existence of CM lifts. Okay, so you want to show that this correspondence is non-empty. So what do? You choose this, like a special point on one side. You kind of transfer the torus to the other group. You get another special point, and you want to show that there's actually a quasi-Schrödinger between them, and that's what they proved using their new CM theory. Okay, and then by result of Kissen, on both sides, everything can be hit by special points. So this way, you can fill up the entire correspondence. Okay. So this cannot work in general if one of the groups is not quasi-split. Because it's well known. I mean, there are these examples of rapport already in the 80s that if your group is not quasi-split, it could happen that all the special points all reduce to the basic locus. Okay, so then, and if your correspondence is should be supported over some Newton stratum which has no special points, then this method tells you nothing. Okay. So we argue instead by, so instead of reducing to tori, we reduce to the cases handled by Xiao-Zhu. Okay. So how do we do that? So already, like in this work of Kissen and Rongzhou, they also, I mean, Rong mentioned this briefly on Monday, that at some point you need to replace the Shimura variety with a bigger one, which is quasi-split at P. Okay. So we choose some F over Q totally real and replace kind of G X and G prime X prime by kind of HY. So H is it's basically restrictions of scalars from F to Q of GF. Okay. It's almost this, except that these things are slightly too big, so you have to make them slightly smaller to make them Hodge type. So this is this is an isomorphism on derived groups. So I'm going to make the cocenter slightly smaller. I guess with the kind of product Shimura datum, such that G so HQP is quasi-split, and this class AP is 1 in H1 QPH. Right? So to get the second thing, I need to use my assumption that this intersection is connected. So now I do the same with G prime and X prime. So now I'm in a situation where and maybe I also need unramified at P. Okay. But you can always make you can make a group quasi-split over an unramified extension. You can kill cohomology classes over an unramified extension. So this is okay. And now I'm in a situation where the results of Xiao-Zhu apply to these bigger groups. Okay. And the kind of crucial idea is that you want to choose F over Q Galois. Okay, so choose F over Q Galois with Galois group gamma. And maybe I need it to be same everywhere. Okay. So now I have some Galois group acting on my bigger Shimura variety. And the third theorem is that we can recover the smaller Shimura variety from the bigger Shimura variety by taking fixed points. So take this integral model. So maybe there is a cofinal collection of K upper P in G of the finite, in H, the finite dells away from P, such that I take S, and I guess I'm going to take these gamma stable. Okay. So if I take a gamma stable compact open subgroup, then it even acts on the Shimura variety, this Galois group. So there's a cofinal collection of these gamma stable compact open subgroups, such that, and I guess I'm going to choose my Iwahori to be gamma stable as well, that if I take this canonical integral model at Iwahori level, such that if I take the gamma fixed points, this map is a universal homeomorphism. And an isomorphism if P is co-prime to the order of gamma. Okay, so this is, let me give you an example of what's going on here. If G and X is GL2, okay, then this HY is this kind of Hilbert-Blumenthal Shimura datum. And I'm saying that the moduli space of elliptic curves, okay, this is the Hilbert-Blumenthal, so this is moduli space of abelian variety with an action of OF. How does the Galois group act? It takes something with an action of OF and it precomposes with a Galois automorphism. Okay. And I'm saying if you take gamma fixed points of that for some good choice of level, you get back this modular curve. Okay. That is more or less Galois descent for F over Q, at least on a generic fiber. So this is a kind of a Galois descent statement that you can recover F vector spaces with some of the gamma fixed points of F vector spaces is Q vector spaces. That's morally what's going on here, except it's a little bit souped up. Okay. Okay, and then how does the rest of the proof go? I look at all the terms in my 6-term diagram, and I apply gamma fixed points, or maybe like a stacky version of gamma fixed points. And I just prove that if I do that, I get the thing for the smaller group. And I have to prove that gamma acts on the correspondence as well. So maybe I should write something down. But somehow this is like, I mean, this is a little bit of reminiscent of what Troyman and Venkatesh do on the generic fiber, right? So they, I guess, if you have a cyclic P group, then it's a little bit like what they do. And in fact, I wonder if this result can be maybe used to do a kind of Smith theory for mod P coherent cohomology. Although this thing being a universal homeomorphism is maybe problematic for that. I mean, I don't know if you always expect it to be an isomorphism. I mean, there's some. So I claim that you can go from elliptic curves up to isogeny, right? To abelian varieties of dimension f over q up to isogeny with an f action. Okay, and this is E goes to E tensor QF, induces an iso. When, I mean, so essentially, like, you want to look at gamma equivariant objects in here, like in Galois descent, and then you get an isomorphism. So induces an iso when applying homotopy fixed points or gamma equivariant objects to the right-hand side. And when you do Shimura varieties, you've rigidified all these things. So you've added some level structure which rigidifies everything, and then you're just applying gamma invariants. But really, I'm applying gamma homotopy fixed points to this category with the gamma action. Okay, so for the interest of time, let me say something about the rest of the proof. So proof of theorem 2 and 1 from 3 is take Xiao-Zhu, take the result of Xiao-Zhu, and apply gamma fixed points everywhere. Okay, so gamma fixed points of the stack of H isocrystals is a stack of G isocrystals. So yeah, you can kind of you take gamma fixed points everywhere, and then taking gamma fixed points preserves Cartesian diagrams. So you get something which sits in these two Cartesian diagrams and does what you want. Okay. It's almost true. There are some issues because I mean, I've replaced. It would be better if I could work with the actual restriction of scalars, because I have to take this smaller thing. There's a little lie here. Okay. So proof of theorem 3. So theorem 3 will be kind of in its own paper, but let me have a look at the time. Okay, so basically what you do is you look in Serre's book on non-abelian Galois cohomology, right? And you're looking at like some question like this. Maybe there's some level here. Y times H of the finite adels mod K, gamma fixed points. And if you look at this from the perspective of non-abelian Galois cohomology, then there are kind of two obstructions. So relevant to compute is first there's H1 gamma K, you would like to vanish. And the second thing you would like to vanish is the kernel of H1 gamma H of Q to H1 gamma H of the finite adels. So Serre's book tells you, look at these things. If they vanish, you win. Okay? So unfortunately, I don't know how to control either of these. So that's a little bit unfortunate. So the issue is, again, I'm working with this weird H rather than the restrictions of scalars of G. Okay? So if I'm allowed to put, so maybe I'll call this restriction of scalars H tilde. So if I'm allowed to put H tilde here, if I put an H tilde here, then what you get after some computation is you get precisely the kernel of SHA1 QG to SHA1 FG using kind of inflation restriction. Okay? And if I'm allowed to put a K inside of H tilde, the finite adels, then I can show there are always many of them where the cohomology vanishes. Okay, so for it's easy to compare this somehow to the Shimura variety for H tilde, or rather the Shimura stack, because it's not a fine quotient. And then I'm going to squeeze this. So I'm going to squeeze this in between H tilde, Y tilde, between this stack. Okay? And using non-abelian Galois cohomology, I can show this map is an isomorphism. So I'm taking the homotopy fixed points of this stack, the stack quotient. Again, the issue is this H tilde does not satisfy SV5, so this is not a fine quotient, even for deep K. And then I'm going to squeeze this in using a kind of argument of, I guess, Deline, maybe Kissen and Lovering. I'm going to try to show that this map is fully faithful. So I'm going to interpret, I'm going to show that H1 gamma K tilde vanishes for many Ks. I'm going to show, I've assumed that the SHA is trivial, so that's good. Otherwise, I have to work with extended Shimura varieties. And then there's some finicky argument that squeezes this in between these two, into this isomorphism. Okay, and how do I go from the generic fiber to the integral thing? I use the local model. I mean, if P does not divide the order of gamma, I just use the local model diagram. And I use the fact that if I take fixed points and the group doesn't divide the order of the residue field, something smooth stays smooth. And if P does divide the order of gamma, I have to go to V-sheaves and use the theory of Papas-Rappaport. And I have to compute explicitly like the fixed points of their deformation spaces. And I guess, I mean, okay. You can ask me what happens when P is ramified in F, but there's something to do. And I'll end here.
Now you can compose it with the transfer, so you get the self-corresponding.
Yes, maybe. What it should be is the usual self-correspondence restricted to the relevant Newton strata. So the usual is just, say in some PEL cases, just moduli space of p-power quasi-isogenies respecting extra structures. The moduli space of p-power quasi-isogenies between fullbacks of abelian varieties respecting extra structures. So it should be something like that, but then you have to restrict to the Newton strata you see on the other Shimura variety. That's my guess.
I might just miss it. Does this universal homomorphism seem slightly weaker than the isomorphism? When you say you kind of apply this, that contradiction, or I mean, I guess kind of understand.
So when I take perfect special fibers, universal homomorphisms become isomorphisms. So that's useful.
Again, you should take perfection of the state. Is that really necessary, or is that essential?
I mean, to phrase the conjecture, I need to use Stukas somehow, and if you give me a theory of Stukas that works for all FP bar or all FP bar algebras, then you could phrase a conjecture. But yeah, I'm not. Yeah, so. But again, you have to be. Yeah, so maybe there's something prismatic. I don't know. Yeah. That should be.
Yes.
It's maybe it's a bit subtle, like, because you use some Hodge embedding, right? So certainly if you have, you would have to check that it doesn't depend on the choice of Hodge embedding. That's probably doable, and then yeah, that will require some work.
Guys, easier question, does it depend on this choice of F and H and so on? So
no, I don't think so. I think you can give I can give a definition of the space without that, and then yeah, just showing it's non-empty requires this choice. Maybe I'll make one more remark. I like this what's next slide in the talk this morning. So what's next is you can also hopefully use this to classify isogeny classes in Shimura varieties at primes that are not quasi-split, using a kind of reduction to the quasi-split case trick.
Questions? Oh, there's one more. So you mentioned the specific method involving scalars of the GSP.
Yes.
Could you say more about what the general result is in that test? What does this new space in parking down the varieties? How large is it?
So on the smaller Shimura variety, it should be the entirety of it, and on the bigger one, you see kind of. I mean, suppose that is real quadratic. So then the Newton strata are like, they're kind of the indexing set is a product, right? So you have Newton strata in direction 1 and in direction 2. And in direction 1, you can take any B, and in direction 2, you need to take a basic B. And that should then correspond to, yeah, those should correspond to the smaller one.
There's somehow an actual generalization to the zeta case of the group.
Yeah, so I think like those kind of considerations are really like similar to Chen and Zhao. The formulation. I mean, yeah, although the correspondences, the geometry is probably hopelessly complicated in that case.